All right, mic check 1 2 3. I'm gonna do that from now on. So welcome to I think Good Choices. This is just for the fun of it. It's the Automate Your Network by John Capobianco series. I'm just really enjoying this book. It's almost helping me overcome like some PSD or something from my own network automation efforts because I'm really familiar with like that old way. I've seen that a lot in my career. But where I've got like, PSD is like, I try to like bring the new way to it, but I'm just not, and back then it was like this new way was still being hashed out and evolving. So like there wasn't really a nice, clean way to bring the new way to an old way type of environment because the new way was software defined networking, and all software defined networking does is it centralizes the control plane and leaves the data plane decentralized still, and then a lot of that is done through expensive new network equipment that bloats your network even more. So like, what I want to do is decentralize all touches to the network. Sorry, centralize all touches to the network for whatever reason. And I want to do that without bloating the network through extra devices, except for maybe a jump server if it doesn't have it, which bloats the device quite a bit because the jump server, uh, especially if you want things to be, if you don't have an out of band management network already, you should probably build that whether you want the new way or not. But especially in the new way, I think that's extra important because, um, in the old way, you can blame somebody for a mistake, but in the new way, what you blame is the method, and then people will try to peel off that method, saying like the whole thing doesn't work because it caused this one thing. So like, as I mentioned in my last video, there's I think it was either in the LPIC or this one, but I want to really harp on this because this is key to being safe on the network. Um, so oh yeah, it was a LPIC, so that's good that I'm bringing it up because it's not even a part of this series. So during the pandemic, there was information published by the Swiss government that made the point that while no single pandemic safety measure uh, is foolproof, doing all of them together is way less foolproof than doing any individual one. So same thing with network safety. You can double check. You can use a staging environment. Any one of these things, peer reviews, logging, is not foolproof. But if you do them all together, you're going to be really well protected. So the other thing I would put on this is out of band management network. So like having that is going to be a big deal because with the old way, when people are at the command line, what happens when there's a mistake? Somebody gets blamed. With the new way, when there's a mistake, what happens? The new way gets blamed, and it gets reverted to the old way again, which it's like it makes no sense, but it's just the way people work sometimes. It's like, you know just following your gut sometimes isn't the best way to make billion-dollar decisions. Um, and people will do that if there's a mistake, if there's an issue in network safety with this new way, especially since they don't really have somebody to blame the way they did before. I guess they could blame the person behind the network automation, but that's the same thing. Okay, fire that person, going back to the old way. In that case, you can try finding someone new, but it's the stakes are higher, I think, because of how many devices you're touching, and then because of the impression you're making about the new way, especially if it's a first impression. They've never really tried anything like that before. So you gotta be safe on your network. This Swiss cheese method of stacking methods together that are not foolproof themselves, but when all stacked together are very, very secure. That's the way to go. All right, so now we're on chapter 3, how to automate the network. So change can be frightening, and the temptation is often to resist it, but change almost always provides opportunities to learn new things, to rethink tired processes, and to improve the way we work. This is by Klaus Schwab. Not sure who that is. Probably, I've heard of Charles Schwab. So Klaus Schwab is a German engineer, economist, and founder of the World Economic Forum. So sounds like a guy who knows what he's talking about. And I guess I want to read that again. So the World Economic Forum, what is that? Let's see. I don't know what this is. So the World Economic Forum is an international non-governmental and lobbying organization for multinational companies. So, yeah, this guy is, he created an international non-governmental and lobbying organization for multinational companies. Let's read again what he said. So he said that change can be frightening and the temptation is often to resist it, but change almost always provides opportunities to learn new things, to rethink tired processes, and to improve the way we work. So that's kind of similar to what I was saying before. The temptation is often to resist it. So like if you're not safe on the network with your automation, that change of bringing forward a new way to think about network management, it's going to be resisted. So most important thing, be safe on the network no matter what you're doing, old way or new way. All right, so next section, how to prepare the network. Network connectivity is obviously a key element of the solution. Network engineers, server administrators, the IT security team, and network operations need to collaborate and determine the architecture for the network automation ecosystem. Communication dependencies between the network devices, the Linux environment hosting Ansible, VS Code, and TFS exist. For example, if you can't SSH from the Linux environment to the network, good luck with Ansible. But that's for provisioning. You also use Ansible to create your source of truth. So that's if you want to do provisioning. This guide is designed to help prepare any possible firewall rules. There we go. So like the ACL on the devices themselves, or traffic flows. So if you can't access devices that are required depending on how the network is zoned. And oftentimes really good network architecture, especially with security in mind, does I forget what it's called, network segmentation. So like if you just plop a Linux environment on a network, if that Linux environment can reach the entire network and isn't zoned within, a certain area of the network, that's a security vulnerability anyway. So often servers or workstations that can reach network device management consoles are in a different or highly restricted zone on the network, separated from the operational zone devices like servers or workstations. If a jump box methodology connecting from operational zone workstations to management workstations where administrative toolkits are hosted create standardized all-in-one Windows or Linux hosts with VS Code. Oh, so if you are using a jump box methodology, so this assumes that you have a device that connects from operational zone workstations to management workstations where administrative toolkits are hosted. Create standardized all-in-one Windows or Linux hosts with VS Code and Ansible install. This is if you are using a jump box mentality. These hosts require communication to TFS and the management console of the network fleet. Okay, well, what if you don't have a jump box methodology? All right, it doesn't say. That's kind of a problem. Um. Okay. So like a jump box would be to connect operational zone workstations to management workstations, and then on the management workstation you'd have like your network monitoring software. So it's like how you can. So it's like you have this one, like source of entry, like this bridge between your operational zone and your management zone. Um, but I guess I'm not sure. Yeah, I guess this is the case. So if you have a jump box methodology, then it's easy. You just create the standardized all-in-one Windows or Linux hosts. So you set up your host. Uh, using this jump box. So you set up like a new jump box, or you set it up on the just existing jump box, and there you go. That's really easy. If you don't have it, then you're going to need to figure out how you can connect to the management, connect to the network somehow. That's going to be a part of what you figure out, which is not easy. All right, so it is recommended using device host names in the Ansible host.ini file, which allows domain name DNS resolution from the Linux environment to look up the IP address of the network device it is trying to reach. Used host names where possible instead of IP addresses in the IAN host.ini file. Either populate the DNS server the Ansible host is using with the DNS records of the network devices, or statically update the local hosts file in the jump box itself. Again, DNS is recommended over a static Linux hosts file, or using IP addresses in the Ansible INI hosts file. I wish they would talk more about that, because from what I understand, the reason you would want to use DNS or use device host names instead of device IPs is if the device IPs change. Then you can continue using the host name, and you can just connect to that new IP seamlessly, and that makes a lot of sense if you're using like DHCP. Those might change. The possibility of them changing is fairly high. Where it kind of I wish they would talk more about is like, what if your DNS names change? Like, is it and hey, you know what, we have the AI, so let's ask the AI, which is wonderful. I'm in the future. I do not need to think as though I weren't in the future, because I am in the future. All right, so let's ask okay, so the question we're gonna ask is okay, yeah. So there we go. And then we'll use the voice tool to ask the question. Okay, and we got to. Oh, here we go. Look, they might just answer it for us anyway. So
if you have multiple environments, dev, stage, prod, using DNS allows you to switch between them easily without changing the underlying configuration files. DNS versus static host file scalability.
Okay, so here's our answer already. Why use host names over IP addresses? So the first reason is readability and maintenance. Host names are human readable, and thus easier to manage. Which is such a weird. The concept of human readability to me is like so weird, because let's look at Chinese writing. Is this human readable? Is this human readable? The answer is yes. Billions of people throughout history have read this. So the answer is yes, this is human readable. So like, how can you say, and let's look at Russian. Russian writing. I guess I'd have to say traditional. Traditional. Yeah, traditional Russian writing. Is this human readable? Yes, it's human readable. Everything is human readable. Humans can read anything. You can make up a language. For example, C, the most complicated. Let's do this. Most complicated piece of writing ever. Writing syntax ever. Um. Okay. Is this human readable? You know, you might think, no, it's not human readable. But guess what? Yes, it's human readable. Humans read this and humans can read this and work with it. Humans are neuroplastic. They can interpret things and they can use, this is human readable. Everything is human readable. So I guess what they mean by human readable, I'm going to say this. So the term human readable kind of upsets me because everything is human readable. If you are from the Western world and live in North America, in the USA, you might think that Chinese is not very human readable, but you would be very wrong about this because people in China have been reading and writing using what you think is not human readable for thousands and thousands of years. So to say it's not human readable is to say that humans are not able to read it, but yet humans have been reading and writing with it for way longer than they have been reading and writing with things that you would think was human readable. So what does human readable actually mean, and how can you definitively say something is more human readable than something else?
B. Term human readable in the context of technology typically means that the data is in a form that is easy to understand without requiring specialized knowledge or additional processing.
Okay, that makes sense.
However, you bring up a valid point about the relativity of this term. Human readable can indeed be subjective depending on one's background, training, and familiarity with a given domain or language, including spoken and programmed languages. In technology and computer science, saying something is human readable usually implies that it's readily understandable without requiring additional steps like decoding, converting, or mapping.
That makes sense.
For instance, the hostname web server 1.
Yes.
Company. Com is easier to understand at a glance than its corresponding IP address 192.
Because you have to know what an IP address is.
1. 1 because the hostname contains a script of identifiers, web server 1, company. This doesn't mean that IP addresses aren't readable or understandable.
Right.
It just means that they usually require more cognitive processing or context to understand what they represent. A network engineer who deals with IP addresses daily might find them as readable as hostnames. Your point on the cultural and geographical aspects of readability is spot on. Readability can be culturally and individually subjective. What's easily readable for one group of people may not be for another, as you illustrated with the example of Chinese script.
Yes.
So, in summary, the term human readable is often used to describe a DAF format that is straightforward and easily interpretable for the intended audience, but it's essential to remember that this can be quite subjective.
Exactly.
Now,
but I mean, this kind of makes sense because, you don't have to know what an IP address is. But that's the other thing is like that's not a feature in my opinion. If your goal is to work with host names, you should know what an IP address is. That's a good thing. Like it's a feature, not a bug that you have to know extra things. Like it's like if you don't know what an IP address is, don't mess with my host names. I mean, at the same time, like, there's different use cases. So like, I don't want anyone who, looks up cute cats to have to know what an IP address is. Like, all you want to do is look at this picture. Then, I want to live in a world where you can look at these pictures without being a network engineer. Okay. So, I think, so I read this, and then we learned about more reasons why you would choose, why you want to use host names over IP addresses, human readable, which, as I said, is often subjective, but they have a fair point. You don't want to have to learn every little tiny aspect of PhD computer science just to understand what the name of a device is. Like you don't. It's like if you want to know my first name, you shouldn't have to read a history book or a autobiography about me, a detailed autobiography about every year of my life. Like I should be able to just tell you what my first name is without any extra information. So that's what they mean by human readable. and that's not machine readable too, because machine readable, that extra information is not optional. Like it's a machine. Like you have to tell the machine exactly how to run. So that's the difference between human readable and machine readable. Human readable, you can condense things down and have people operate with less information than would be necessary to communicate that to a machine. A machine needs more and more specific information than a human does. All right, and then dynamic infrastructure. So if you're changing, if the IP addresses change frequently, then of course you would use the host names because they change less. If the host names change frequently, then you would probably use the IP addresses because they change less. But in cloud and dynamic on-prem setups, it is more common that the IP addresses change frequently. And then if you're using DNS, you don't need to worry about changing those IP addresses. They'll resolve automatically. And then the other reason is you can have an agnostic environment. If you have multiple environments, as you need to, dev, stage, and prob, then you can still you don't have to. So you can switch environments because you don't have to change the if your dev, stage, and prod uses different IPs, again, you have that same advantage where you're just accessing the device through its host name, and now you don't have to remember and look up the IP scheme for your different environments. Yep, and then there's also, because now if you use host names over IP addresses, then that presupposes that you have DNS set up, and DNS is important to set up because it's scalable. Because it's centralized, so you can see everything in one place, all your mappings of IP addresses. You can see your IP address stream just in one place. You don't have to go from the device to device to see what is configured on them. DNS is fast. The entries are cached, so like there's no, it's not any slower than doing it the other way. And then you can do extra things with DNS. You can load balance, you can have failover, and you can do geo. You can have multiple DNS servers for redundancy. So there's no trade-off in it being less robust either, because in fact it could be more robust because you no longer have a single point of failure. You can distribute your servers across geolocations, and it's even more robust and resilient than a static host file. All right, so that looks good to me. Let's keep going. So here are the communication flows required for network automation. So if our source is Ansible and we want to do provisioning, we have to have SSH set up. Don't use Telnet because it does everything in plain text. Use SSH. The other thing with SSH is you can bypass passwords because you can have it save the key. So like you don't have to send passwords at all. You just send public keys, and as long as you don't send the private key, it's like that's the best possible way to securely send information. Way better than Telnet. Don't use Telnet. And then your destination is going to be the network devices. So another communication flow required for network automation is if you're sourcing from Git, you need to, this is the version control, this is the repository, this is where you'll do the diffs and everything of your image. So you got to have a connection to your GUI, your server, where you have that database and where you can use a front end application like in Chrome, like a browser Chrome, to handle all that information. So the destination is your DFS. In this case, it's going to be like a Microsoft Azure Progress, TFS, not DFS, but whatever you're using for that is going to be the destination. And then the WebDev, SWebDev ports, S for secure, that's the port you'll be using. So the network devices do not need to communicate with TFS, and Git does not need to communicate to the network devices. place tools into the appropriate zones or open the appropriate firewall rules to permit these communications. So that's an advantage as well. It's like your provisioning is separate from your source of truth. So like, if something happens, it's not going to alter the like the source of truth. Like they're not connected into one flow. So like that can be useful because like if this fails halfway between, you're not you can have it's not all one communication flow, which can have advantages. Okay, so next is what tools are required. I'm gonna pause and be right back. All right, I'm back. Let's keep going. So, what tools are required? Microsoft TFS. The Windows administration team needs to set up a TFS environment. If one does not already exist, they will establish the architecture for TFS and follow the installation instructions. So I'm going to follow along with this book in my lab. So I think I'm going to take this time now and set up TFS in my lab. So I'm going to open my lab. All right, and then I'm going to open my Automate Your Network project that I have. Then I'm going to cry because there's no space left on the device. So I guess I'm going to investigate that. Let me use ChatGPT. How can I resolve this issue? Yeah, the storage drive has run out of free now. I'm sorry. So let me see. So this is the device running GNS3 is a Dell R610 server running Ubuntu Linux. And I think it's a Dell R610. I can't remember. Yeah, it's a Dell PowerEdge. Yep. Yeah, this is it. I don't have this fancy thing on the front with it, but that's because I got it refurbished, so it doesn't have. It was pulled off from. Yeah.
I see. The fact that you're using a Dell R610 PowerEdge server running Ubuntu Linux adds a different angle to resolving the no space left on device issue. Since mastering network automation is a career goal for you, understanding how to troubleshoot this kind of problem on a Linux-based server can be a valuable skill. Check disk space SSH into the server. Use SSH to connect to your Dell R610 if you're not already directly connected. Disk space. Run DFH to see available disk space. Bash copy code DFH free up space list large directories and files. You can use the do command to find large directories. Bash copy code DUSH. This will show you the sizes of directories starting from root. Remove unnecessary packages. Use after apt-get to remove packages that you don't need. Bash copy code sudo apt auto remove clean package cache. You can also clean up a package cache to free up space. Bash copy code sudo apt clean delete old logs. Old logs can consume a lot of space. Navigate to var log and manually delete or truncate old logs. Bash copy code sudo truncate s0 var log manual removal. For non-system directories and files you can delete, use the erm command carefully. Bash copy code mark path to directory GNS3 configuration change to default directory. GNS3 configurations are stored in any file which can usually be.
All right, these are all great suggestions, so let's go through them. Yep, number 1 is complete. I logged in. Number 2 is complete. I'm looking at the available disk space. Now, I don't see an SDA3, so I think that could be the issue. So how come I don't have an SDA3? Let me do that. How come I don't... frustrating. Oh, yeah, okay. So, it looks like the root file system Is that 100% zero? Yep. So given that you have 48 amount points showing almost zero usage, this is indeed surprising and concerning. So yeah, something's being saved to the wrong place. So okay, so we're gonna locate now yeah, let's keep going on this. So we did this one, so now we can see um yeah, so here's the one that's 100% utilized. That's a problem. So let's look at some large directories and files. Maybe try that with sudo again. Okay. Oh, is that not my sudo password? Oh, right. Okay, something else. So there we go. Yeah, nothing that large, which is surprising. Now these are all problems that are like, assuming that your file system is designed the way you want it designed. Like these are all good things to do, but like for me, like I'll do all these, just because it's probably a good thing to do. But you know, the problem is that I'm saving things to the wrong area, and that I don't have, uh, even though I have uh, a disk that okay. So this is yeah, log files. I don't have any of those. Okay, so this is where I think the issue is. So we need to change the default directory. So GNS configurations are stored in an IDI file. So let's see if we got that. So we're gonna do cat dot config slash GNS GNS3 GNS3 server dot conf. So yeah, here might be the problem already. So you can edit this file to change the location. So let's do this. Let's do which GNS3 server, and let's do which with the underscore as well, and let's do it with a dash as well. Okay, so that's good news. We've only got it for this. So I'm gonna change the directory into here, and then do ls-a. All right, so that file doesn't exist. Let's do this. CD here, and then we'll do a find dash name GNS3. Okay, so we do have that config file. We do have this config folder where it was expected to be. It's okay. It's just at a slightly different location. So is it under appliances? Oh no, these are all my valuable images that I hope don't get deleted. Oops, but that it looks like I deleted them all. No, I just severed my connection. That's fine as long as I didn't delete all my valuable images. All right. So, yeah, we're missing this file. So maybe it's this. Let's see. Oh, see now here's the settings. Like this is the wrong version. Why is it like that? Why are you like this? Yeah, okay. That is wrong. Okay, so let me ask the AI, because we live in the future. First, let me try to exit from Vi, which is something that requires a PhD in computer science. All right. So now what I need to do is ask the AI. So we're gonna ls this GNS3 GUI. There we go. And then we're gonna feed this into the AI. We're gonna say, and then before that, we're going to do GNS3 server dash dash version. Uh, okay, there we go. What the hell? I'm so confused. I'm so confused. So why are the version numbers so far off? When I boot up GNS3 and connect to it on my server, it is clear that I am running version 2.2.42.
Between versions could be due to various reasons. One possibility is that multiple installations of GNS3 server exist in your system. Another reason could be that the version information is not getting updated correctly. Let's break it down. Multiple installations. Sometimes multiple installations can exist on different paths. You can find out where the versions are located using which. Bash copy code which a GNS3 server. This command will show you all the locations where GNS3 server is installed. Check Python environment. The import lib underscore metadata. Package not found error suggests that the package isn't found in your Python environment. Are you perhaps using different Python versions for running the GNS3 server in the client? Maybe one is using the system Python and the other a virtual environment. Profile skimming. The GNS3 underscore way. Conference file you showed is specific to the way. Configuration file specific to the server will be in a different location, likely under, etc., GNS3 or tilde.
Oh, okay.
Config, GNS3, GNS3 underscore server. Conference. Check those to ensure that the server is indeed the version you think it is. Reinstall. As a last resort, you can then install and reinstall GNS3 to ensure that only the version you want is present on your system. Given your
Okay, so that's good. So let's do this. Nope, there's nothing there. So let's try this. etc. There we go. Oh, here's the ini file. So yeah, this is what I want. So gns3.ini. Okay, yeah, I think this is what I need. So here's the iOS directory. Yeah, then the projects directory. Yeah, and that's the stuff that we don't want to lose. If I lose that, I lose all my images and I lose all my projects. All right, so let's see here. Oh, this is tricky. Tricky. Okay. Oh, here we go. Why don't I just do this? I can expand the storage. Let me try that. I mean, I ideally I'd like to actually figure it out for real, but how do I update my ini file? I don't see I thought they talked about the ini file. Let me just try expanding, making it so that the virtual disk can expand as much as it wants, because if we do this, and we do so cd like that, clear, and then we look at the virtual disk through what was it, df-h. Yeah, here we can see it's what the hell? It's using 186 gigs. That's ridiculous. I mean, well, I mean, I've got I've got 800, so yeah, let's try that. Let's try expanding it out. Okay. Oops. Um, permission denied. Okay. Well, let's give it a sudo. Okay, so there we go. Oh, this is good. So now it used to be locked at 200, which we see here, but now it's locked at 800. Successfully resized. So now let's resize the file system with a sudo. Probably need that. All right, that seems smart and like it's not risky and like it's not going to put my images and projects at risk for being lost. That seems to be the case. All right, so I'm gonna exit out of there, open it up again, open up my projects. Oh no. What the heck? Did I lose everything? I have a feeling I did. Okay, well, it was just that one. And I've got all my images. I don't know why that one is like so tricky. Like every single other one is fine. It's just this one that's like messed up. What is this?
Message could now load topology, home, gposh, genes3, projects, 0742863D8001, 412C-8ACB1E2CA3503EA, automate underscore your underscore network. GNS3. Expecting value. Line 1 column 1, char 0, suggests that GNS3 was unable to load a topology file. The error is commonly associated with JSON files, and the message expecting value. Line 1 column 1, char 0, usually indicates that the JSON file is empty or corrupted. Here are some troubleshooting steps you can consider. File integrity. Check if the file automate underscore your underscore network. GNS3 exists and if it's not empty. Bash copy code get home gposh genes3 projects 0742863D8001 412C-8ACB1E2CA3503EA automate underscore.
Oh, maybe the permissions are not set correctly. Oh, there's actually well, let's see the permissions for another project. Okay, so this one is here. So this one is 53 EEA. Yeah, so this one is here. Yeah, the permissions look like they're the same. Let's look at the permissions for another one. How about for this one in here? Home lab demo. Okay, well the permissions are quite a bit different, and we've got write permissions where that one does not. All right, let's try one more. This one, the permissions are different as well. All right, one more, final one. Yeah, okay, the permissions are all wrong. All right, well, let's change the permissions. Uh, so, what do I feed into mod to make these, to make a file match these permissions settings? Ah, oh, it tells me that right there. Okay, so we're gonna use the symbolic method. Yeah, there. Let's use the symbolic method or the octal method. Symbolic method is better because then you don't have to remember the octal method. So I'm going to change here, CD there. Oops. CD to here. There we go. And now I'm going to delete the backups because deleting backups just, it makes so much sense. If there's anything in the world that makes sense, it's deleting the backups and then doing something on the original file that might corrupt the original file. That is the world's, that makes more sense than like anything else in the world. Like 2 plus 2 equaling 4, that's complicated. Like it's hard to figure that out. But when it comes to deleting your backups first and then making changes that might corrupt the original file, that's, they should just say that. It's like, instead of it's easy as pi or it's easy as like 2 plus 2 equals 4, they should just say it's easy as deleting all your backups and then making changes to the original file that might corrupt the file. All right, there we go. So hopefully this works now. Nope. You know what? I can just scrap this. It doesn't matter. I don't know why this one is so screwed up where all the other ones are not. But like the other ones are not. It doesn't matter at all. There's literally nothing about that one being screwed up that matters. So, you know what I'm gonna do? I'm gonna delete. I'll create a new one called Automate Your Network. Yeah, that's, I don't know why I'm screwing around with one that doesn't work. I mean, the project was messed up, so like, yeah, okay. I mean, expanding that out because we saw that we only had 200. Oh, you know what was going on? You know what was going on? I know what was going on. So what was going on is we had those processes of like pinging that were going on the virtual hosts, and they were flooding up those files. So that's why it was maxing up the space, is because we never successfully stopped that background process we had that was saving pings to a file. So that file just grew and grew and grew and grew and grew, and that one project, whenever we opened it, crashed the disk because it kept trying to save to that file. So it kept trying to go beyond the maximum that the disk could support. So doing it out to 800, kind of makes sense, but it kind of doesn't. I kind of want to put it back down because I like it to where that scenario doesn't blow out the whole lab, so I like to limit it down. So here's what I'm gonna do. I'm gonna do the sorry, the DF-H. You can see I do have some mild dyslexia. I never really used to have mild dyslexia, but in my mid to late 20s, I had kind of an incident, and ever since then, I actually have mild dyslexia. But it's mild. It's not a big deal. All right, so let's move on. Yeah, see how we have 823. I'm afraid that if something goes wrong like that, it's just gonna blow away the whole. Oh, but okay. It looks like the used space actually didn't go down that much. All right, I have no idea what's going on. I'm just gonna leave it and move on. All right, so the Windows administration team needs to set up a TFS environment. If one does not already exist, they will establish the architecture for TFS and follow the installation instructions. TFS supports either distributed or standalone deployments. After installation, secure TFS with a signed certificate to offer hypertext transfer protocol secure HTTPS and secure sockets layer SSL services. Oh, after installation, secure TFS by doing that. Active Directory username and passwords can be required to allow Git interactions with TFS, primarily for Git clone, Git pull, and Git push operations, or keys can be exchanged between the Ansible host and TFS. Once TFS is installed and available, determine the TFS administrators and assigned role-based access controls, RBAC. Create the base repositories for the environments, lab, production, along with the master branch in each repository. Git is natively supported in TFS to select. So select Git at the repository type selection. Assign permissions to the repositories and distribute the TFS workspace hyperlink to the network administrative task. TFS also acts as a graphical front end for Git, representing all the important information found in Git, such as commit details, in an easy to use, feature rich ecosystem. This book is not intended to be a detailed guide in TFS administration or installation. Please refer to the following guide from Microsoft for further instructions. Okay, so I want to set up TFS in my home lab now, so let's do that. And let's make it nice and easy so I can not have to worry about clipboard issues in my VNC. And then let's set the VNC back to what it was because it's asking annoying questions. Oh, I don't know what I did before to change it. Maybe. Oh, I hit edit, and then yeah, I changed it to ultra. So I'm gonna change it back to tight. All right, and now here's our network. This is a green field. The first thing we have is a connection from our ISP. So we have an internet connection here. So ISP internet connection. All right, and then the second thing we have is just a jump host on the so this is going to be our automation server. All right, and we have like okay, so we can't have spaces. Okay, there we go. That works. This is the automation server, and we have like a box here, that oh, I thought this works. I guess this doesn't work anymore. But okay, yeah, this one will be fine right here. If I were to do new template and get an appliance, and then go to guests, we would have like a built-in one that's like more ready to go. But like the point is, I want to do it with something that isn't ready to go. That's kind of like the whole point. Is I want to build everything from scratch. I want to be able to go and like, you know, just basically revolutionize everything really quick and easy. Oh, and these are actually showing up now. All right, but I deleted the image, so I need to reinstall it. It's just something included with GNS, so it's not a big deal to just reinstall. It's not like the Juniper images that would be a disaster. So this is a guest, and it's the it starts with an N, the network automation guest. Okay, so now maybe it'll go faster. Maybe not. But the point is, we have our automation server now, and then we need yeah, let's do 3 adapters. So we need internet connection. All right, and we'll take a look at the difference between this box and this box. This one might be better. So this one takes us right to the okay. This one needs internet. Let's give it internet. Ow, and we've only got one. Add. I can't do it if it's already connected, so we'll disconnect. All right. Configure. There we go. Add. And then configure this. Give it another, so it matches the same numbers of adapters. This is ENS0 to ENS1. This is, oh, wait, why is there only one? Oh, there we go. Okay, that's better. To 2. There we go. Now it's taken quite a bit for that. Okay, that's good. We've got them started up already. So let's take a look at the difference between these two. We got a connection refused on this one, which is problematic. See, like, this is why I use this one, because this one works. Use the one that works. If I get another connection, yeah, I got another connection refused, so bye-bye. I feel nothing. I feel no pain in doing that. It's addition by subtraction. Yeah, and it takes forever to delete. This is the image that really works for me, so this is the image that we're going to use. Probably makes sense because it's what my actual lab is on, you know, running Ubuntu, so it's probably easier to virtualize Ubuntu images. I don't know. I have no idea. All right, so now it's not asking for that annoying password. So let's clean this up. All right, and now we have Microsoft Firefox. So here's the cool thing: we can go to oh, we have to configure the internet, right? No, the internet's gonna automatically. Yeah, okay, we're good. So we can go to YouTube. We can watch YouTube in the virtualized session. It just takes longer. There's a lot of latency. But most importantly, we can go to my GitHub page. F no. All right, so here's my GitHub page. This is a donut I'm looking through. So what we got now? We got where's my repo that I'm working on here? Ah, here it is. So yep, we've got the fork. All right, perfect. Okay, so now what we can do is we can get this same thing I've got here on VS Code. We can get that on my virtual environment here. So let's do that. We're going to get VS Code. Okay. Gonna get it for Linux, for Ubuntu. There we go. We want to software install. The other thing I'm gonna do is get Chat GPT. I don't know why there's two of these open. Don't upgrade, please. Please just stop. Please just stop. Okay, it's a schoolyard bully. It's not gonna stop. Oh, here we go. Here we go. Okay. Yeah, don't upgrade, please. No, it's a schoolyard bully. It's just gonna keep. Okay, well, I guess the only thing you can really do is just ignore it. So it's okay. It's up there. It's annoying. That's okay. Just keep on going. So I'd like to log into ChatGPT, but that's also being annoying. This is being annoying as well. All right, install. All right, so okay, I think it's doing it. Try hitting. Maybe I can just hit enter because it's already. Ah, there we go. Okay, yeah, I can enter. This is going. Let's see how we're doing on. Ah, okay, now we're at ChatGPT. Log in with Google. Okay. I need to change my posture. Alright, then I need to enter my password. Alright. Don't save. Oh, now I need two-factor. I have no idea where my phone is. I think it's in the other room. So I'm going to worry about this later. Um, right now, the most important thing is getting VS Code on there. Um, so, and then we're going to get the TFS up. So I'll just give it a moment. I'll be right back. Okay, I'm back, and it's lunchtime right now, and I'm at the hour mark, so I think I can get this TFS working. So I want to do that. At the very least, I can get code running. So let's do this. Let's get the repository copied down. So we need a terminal. And it's really laggy because it's a virtual machine, unfortunately, but um,
Microsoft Team Foundation Server, TFS, now known as Azure DevOps Server, is a set of development, build, test, and release tools for software development teams. It supports the entire application lifecycle management, process, and integrates version control, work item tracking, build management, test management, and release management into a unified environment. Key features of TFS include version control. Offers source code management either via Team Foundation version control, TFVC, or Git. Work item tracking. Provides the ability to create, track, and manage work items like features, requirements, tasks, and bugs. Build automation. Enables you to compile and build applications automatically. Test case management. Helps you manage and execute test plans and test cases. Agile tools. Offers tools for implementing agile methodologies like Scrum and Kanban. Release management. Allows you to manage the deployment process, making sure that the right build goes to the right environment. Reporting and dashboards. Provides extensive reporting capabilities and customizable dashboards to give insights into development progress. Integration. TFS can be integrated with various third-party tools and can also connect with Microsoft tools like Visual Studio. TFS is designed to work both on premises and in the cloud, which offers some flexibility if you're considering remote work. Since one of your major goals is to find a 100% remote high-paying job, understanding tools commonly used in DevOps and ALM could make you more marketable. This knowledge could be particularly beneficial if you ever venture into network automation within a DevOps. If you're looking to steer clear of Microsoft products, there are several alternatives to Azure DevOps Server for source control, project management, and CD, continuous integration, continuous deployment. Alternatives: GitLab Pros. Built-in CD, comprehensive feature set, strong community support, and it's open source. Cons. Can be resource intensive, the user interface may not be as intuitive for some users. Jira plus Bitbucket by Atlassian. Pros. Deep integration between issue tracking, Jira, and source control, Bitbucket, extensive plugin ecosystem. Cons. Costs can scale quickly as your team grows, the two components are separate products. GitHub Pros. Widely adopted, strong community, marketplace for extensions, GitHub Actions for CD. Cons. Free tier has limitations, advanced features can be costly. Jenkins Pros. Highly customizable, extensive plugin library, and open source. Cons. Steeper learning curve, can be resource intensive, setup can be complex. Travis CI Pros. Easy to set up, integrates easily with GitHub. Cons. Limited native support for Monoreposed, less customizable than Jenkins. Azure DevOps Server, TFS, Pros and Cons. Pros unified solution. Integrates issue tracking, version control, build automation, and release management. Extensible. Rich ecosystem for plugins and extensions. Strong integration with Microsoft tools. If your stack includes Microsoft products, TFS integrates very well. Granular permission control. Allows very detailed security settings. On-premises option. You have the option to host it yourself or use the cloud-based Azure DevOps. Cons cost. Licensing costs can be high, particularly as the team grows. Complexity. Can be overwhelming due to its comprehensive feature set. Limited non-Windows support. While it has improved, it's still more Windows-centric. Learning curve. Because it offers so many features, it can take time to master. Given your goals, especially your aim to find 100% remote work and master a niche skill set, understanding a range of these tools can make you more marketable. For instance, GitLab and Jenkins are heavily used in network automation scenarios. If you opt to specialize in network automation, knowing how to integrate your code
Mic check one. Okay, I don't know how much time went by without me realizing that my microphone was off, but I apologize for that. It's like driving an airplane. Apparently, every little tiny thing that will go wrong can go wrong, and there's a lot that can go wrong. So it's back. I don't know when it dropped off, but this is just the next series for me anyway. So my LPIC video should be good. That's the one that really matters to get right. So it's still taking me to my Azure DevOps organization. All right. So let me ask it. If I only want to use open source solutions, do I need to use both Jenkins and GitLab together, or do I only need one or the other?
Popular open source solutions, but they serve different primary functions and can be either complementary or standalone depending on your needs. Let's break down their main roles. GitLab source control. Git-based version control system. Issue tracking. Work item management like tasks, bugs, and features. CD. GitLab CI/CD allows you to build, test, and deploy code within the GitLab ecosystem. Code review. Built-in merge request features for code reviews.
Yeah, so Jenkins doesn't have source control, and it doesn't have issue tracking. Both of them have CI/CD, and then both of them have code review. So here's just the pros and cons. If you only use GitLab, then you get a unified experience. But if you and then the only con of using GitLab is if you already started using something else, and you don't want to migrate it. And then the pros of using only Jenkins is it's highly customizable, but the cons are it doesn't have built-in source control or issue tracking, and you'd need to integrate it with other tools if you wanted that. And then the pros of using both is you can harness the extensibility and customizability of, so Jenkins has like better CI/CD. So like you might want to use GitLab but just use Jenkins for the CI/CD, and then it's more complex and you'll need to maintain two systems, but it might be worth it for Jenkins. So GitLab is a one-stop shop experience, but Jenkins has better CI/CD on it, so it might be worth it. But you know what? I think this is gonna be it for this video. If we look at my right here, it's still signing up for it, which is kind of annoying. But we can try using GitLab instead. That might be better. But you know, I don't know how long the audio issues were a problem, which is frustrating. But yeah, okay. So that's the end of this video. Thanks for watching. Stay tuned for the next one where I read about Git.